Hello, welcome to watch our tutorials on probability and statistics, and subscribe to this channel. In this video, we will talk about Chebyshev's theorem. So, in statistics, the variance of a random variable will tell us something about the probability of the observations about the mean. So if a random variable has a small variance or standard deviation, so we can say most of the values to be grounded around the mean, and the probability that the random variable assumes a value within a certain interval about the mean is greater than for a similar random variable with a large standard deviation. So if two random variables have same mean, and one has a smaller variance, so this means that most of the values center around the mean than variable with a large variance, right? So if we look at this figure with two density function for two random variables, so A and B has same mean value mu, but in A, the values has a more wide shape than in the B, because the total area under this density curve will be 1. So which means in B, the curve will be higher but narrower. So in B's case, more variables center around the mean in a certain range. For example, we can limit the range here, a symmetric range. So within this same interval, for both cases, more values center around in B than in A, right? And what is Chebyshev's theorem? So the Russian mathematician Chebyshev discovered that the fraction of the area between any two values symmetric about the mean is related to the standard deviation. And the theorem due to Chebyshev gives a conservative estimate of the probability that a random variable assumes a value within k standard deviations of its mean for any real number k. So the Chebyshev's theorem states that the probability that any random variable x will assume a value within k standard deviations of the mean is at least 1 minus 1 of k squared. The form is the probability of random variable x between mu minus k sigma and mu plus k sigma large than or equal to 1 minus 1 of k squared. So for example, if we say k is 2, which means the range of 2 sigma around the mean, and the theorem will state that the random variable x has a probability of at least 3/4 of falling within two standard deviations of the mean. That is, 3/4 or more of the observations of any distribution lie in the interval mu plus minus 2 sigma squared. So similarly, the theorem will say that at least 8/9 of the observations of any distribution fall in the interval mu plus and minus 3 sigma. So Chebyshev's theorem is hold for any distribution. Does not specify which type of distribution it applies. It applies for any distribution. That's why the theorem is very conservative. It only states the limit of the probability. So at least larger than a value within this range. At least But if we look at specified, for example, a normal distribution, it will be usually larger than this lower limit. So we know, for example, from a normal distribution, standard normal distribution, the probability of any random variable between the mu minus 2 sigma and mu plus 2 sigma is larger than 0.95, right? But anyway, this theorem is a distribution-free result. So it just states the lower limit, and in some cases, you do not need to have the particular distribution of this random variable, no matter it is skewed or symmetric or other kinds of prerequisites to do data analysis later. You only know this is a distribution random variable. Only know the value of sigma, right, and the value of the mean. So it's enough to use Chebyshev's theorem. So we take a look at an example. A random variable x has a mean equals 8, a variance equals 9, and an unknown probability distribution. So the question is, first, find the probability of x between minus 4 and 20. And second, the probability of x minus 8's absolute value larger than or equal to 6. So solution is, for the first question, probability of x between minus 4 and 20 is same as the probability of 8 minus 12 and 8 plus 12, right? So this is actually 4 times sigma, right? So this probability will larger than or equal to 1 minus 1 of 4 squared. So it's larger than 15 of 16. And the second question solution is probability of ax minus 8's absolute value larger than or equal to 6 equals 1 minus the probability of this term less than 6. So this term less than 6 is actually the probability of x minus 8 between minus 6 and 6. So 6 is 2 times sigma, right? So the form is 1 minus the probability of x between the mean minus 2 sigma and the mean plus 2 sigma. So the result is less than or equal to 1 of 4. Thanks for watching.